much over there. We're in calculus. Okay, so kind of switching gears. We've been doing all the algebraic methods for a while. The graphical methods are a little shorter, which is nice. So if I look at this one here, so the main idea is integrals find area. Derivatives find slope. Integrals find area. So they give me this function f of t, and they're saying, okay, integrate it from -2 to x. Then down here, they're basically saying x is 2. What they're really asking for is the integral between -2 and 2 of f of d times dt. Right, if you just plug in the 2 for x. And then these are just like geometric formulas to quantify the area. You don't have a function, so you can't like integrate it and look at numbers. I'm just literally looking at from -2 to 2. How many boxes are there? So I've got like a 4x4 grid here. That's 16. So then I've got a half of a box there. So your answer is 16.5. Those don't get too much harder. The catch, I guess, is there's not that many of those.
What is FTD like?
So this is like the height of every single point. And this is the width of every single rectangle. Can I just say we'll get to it in a little while?
What is a little?
No. So if I look at the second one here, you're basically plugging in -1 for x up here. So you're integrating between -3 and -1. And the integral is just the area. So you just count the boxes. So 1, 2, 3, 4, and then those two combine to make a fifth. You get 5. Not bad, right? Alright. I'm not gonna like keep going there. I'm gonna skip to, let's look at they're not numbered, are they? Find this page. Got like the 2 to 2 on top. So if I asked you for the integral from -7 to -3, forget that question. If I said from -7 to -3, what would you get? -8. If I said from -7 to 0. Wait, how is that negative? That should not be a negative sign.
Oh, sorry.
Yeah, no, I'm not blaming you. Alright, what's the integral from -7 to 3? It's 8. Like, it's gotta be positive. What about from -7 to 0? 7. -7 to 4? 0. And then -7 all the way across. 7 would be 2. So you notice you're going left to right on all of those. Like every integral we've done so far has been left to right. If they reverse it and go right to left, it changes the sign. So like the rule, if you want the rule, like the integral of a to b is the opposite of the integral from a to b. It's like if you're reading backwards, above the axis becomes below the axis, below becomes above because you're flipping the direction of everything. So what I'm saying is if I asked you for the integral from -7 to -3, the integral from -7 to -3 is 8. Smaller numbers on the bottom. That's like what's supposed to be. if I ask you for the integral from -3 to -7, now I'm going right to left, which is the opposite of the direction we typically read. So up becomes down, down becomes up. That would be negative. Does that make sense? Yeah, totally, yeah. And if you went through and did like the plug-in stuff, like you just end up with f of a minus f of b instead of f of b minus f of a. So you're ending up with like 7 minus 6 and 6 minus 7. Like it just flips the, so you can do it either way. Another kind of rule is if I have the integral from b to b, like this one here is the integral from 2 to 2. Well, how much area is there when I go from 2 to 2? It's 0. You're not accumulating any area, so that's 0. So if these two numbers are the same, you're going to get 0. And if you think about like plugging in b minus plugging in b, like they're just going to cancel out, right? Right? How do you do those? Go to this page. Am I good? Am I going too fast? It feels like I'm going fast, but I feel like we're okay. Are we good? The top one is nothing on. You can just do that when I give you time. This is the one I want to go through. So let's talk through it. If I'm integrating little g of x, so capital and little letters start to matter. It's kind of annoying. That's just kind of the standard way to write it. So what this is telling you. What this is telling you is little g is the derivative of big G. So I like to put them in like a vertical order. Like big G is up there. Below that is G prime, which is also little g. So the point of that is if I integrate little g, what do I end up with? Big G. So that's what this is telling you. So if I integrate little g, I get big G. And then if you look over here, they told you what big G is. So then you can say, okay, x plus 3 squared. From -1 to 7, but don't integrate that x plus 3 squared. That is the integral. That's what they're trying to express to you. Let me just go through that again. This is a pretty major thing. Little g is the derivative of big G. That means little g is below big G. I always think about derivatives going down. So like position and then velocity and acceleration. The integral's going up. So little g is the derivative. It's a level below big G. I can write this either way. So if you're asked to integrate this level, whether you're integrating little g or big G prime, you're going to get up to big G. So I get the integral of little g is big G. I still have my -1 and my 7. I don't need to do substitution or integrate because they're not asking me to integrate. They gave me the integral already. Then you just plug in those numbers, which I'm going to let you do. Does that make sense what I'm showing you there, what I'm setting up? I'll be finished. Too late. I'm not going to finish it. Because I want you to try.
Oh, wait, there's.
Alright. So you're just going to plug in 7 minus
Yeah,
plug in 8. Okay. Back page. So these are kind of annoying. They give you a piecewise and then they ask you to integrate, but it stretches across like both parts. If I do a little number line here, I'm being asked to integrate from -2 to 2. But this tells me at 0, we got split. So when x is greater than 0, which is this part, right? The function is 6x. When x is less than 0, which is this part, the function you gotta find the total integral. So what you gotta do is set up two integrals. This part would tell you the integral from -2 to 0 of 3x squared minus 2x times dx. Plus this part, 0 to 2 of 6x. See what I'm putting where and why? So again, I think it's easiest to start here, -2 to 2. Put the numbers that they give you on the number line also. And then I put 6x to the right because that's the equation when we're greater than 0. I put this one to the left because that's when we're less than 0. And then this part is one of the integrals and this part is another. Does that make sense what I'm doing? And then you have to like evaluate those and add them all up. That's why they're kind of annoying because it's kind of like two problems in one. So there's like three. There would definitely not be more than one of these on your gateway. I'm not sure there'd be one. There'd probably be one, but not like multiple. And it would be a fairly straightforward integral. Otherwise, it just gets super annoying algebraically. So I think that I would like to stop and let you guys work. I got the answers up here, and I'll walk around and check them and help. Is that? Do you think you're like good to do that? Okay. The answers are up here. Welcome to check them. Please check them. I'll watch them. I don't know if you do it right or not. We do some more stuff like this.